taking a look at Lesson 5, Intermediate Functions, Jupyter Notebook 4, Functions with Lists. Okay, we're going to do a couple from the top and a couple from the bottom. So we'll do 4 from this notebook. And I think of the first half, yeah, go ahead and do this first one. Write a function that takes any 3 items and prints 2 sentences with the items in the list and the list length. Put it on a separate line. The results should look like this. So try and write a function that will produce those results. All right, so let's give this one a try. I'll do it the simple way first and then the complicated way. Define my func can receive A, B, and C. We're going to turn those into a list called myList is equal to brackets A, B, C, and then print f string. The new list is brackets myList, end quote, comma, quote, backslash n, which works only in print statements, and then f string, it has length myList elements. Okay, no error messages, and when I call my func and I feed it this true and 42, that works successfully. Now, how would you do that if you wanted to use this with args instead of with simply adding 3 elements? Well, you could say define my func star args, and then, oops, and this is similar to what Max did in his example. For arg in args, first you have to create an empty list. Empty list is going to be that. For args in args, empty list dot append arg. And if you stop right there and you print empty list, it's no longer empty, right? So go ahead and try my func, and it has created that list as expected. And then you could go ahead and do, I guess you would probably want to call it my list, not empty list, because that way we can reuse the same code. Empty list, let's change that to my list. Place all of those. Copy this code. Paste it here. Run that, and that works successfully. But now I can add more than 3 elements, right? This, another, 54, etc. And that's the advantage of using args. In the first example, it had to have exactly 3 elements, and in the second example, it doesn't. So hopefully the idea behind args is starting to become familiar. Notice that I used the .append method. This is incredibly common in Python. to start an empty list, to use a for loop, and then to use the .append method in order to add items to the list one by one until you have a new list. So common that it has a replacement called list comprehension. All right, write a function that returns, let's see, variable, right, index one. All right, this is a tough one right here. Try this, number 13. Write a function that uses plus to concatenate lists, just like for strings. Receive two lists, turn them into a single list, define a new variable. Okay, this one is pretty simple. Define myfunc to receive my list and item. And the simple function would be if type myList is equal to list, then myList.append item myList is equal to, right, there we go again, double equal sign. And then we'll try it out as myfunc, and we feed it a list, 1, 2, 5, and then we give it a new item, it puts them together. And of course, you could have replaced that with args if you wanted to. So I'm going to copy the same code, but instead of myList and item, I'm simply going to put args, and you could say if type args 0 is equal to list, and then you could put in a for loop for arg in args bracket, and then you would want to take 1 and following myList.append arg, and that would mean that everything else would get appended to it, and that would an error function because myList is not defined. Oh, right, because it's no longer myList. It's arg 0. And return args 0. Okay, so compare these two, take a look at the difference between the two of them. Notice how I use indexing here, and I also use indexing here, but indexing with a colon. This assumes that the first arg is a list and everything else needs to get appended to it. Did anybody else get a different way of doing this, or suggestions you'd like to share about how to build that into a for loop with args? Okay, moving forward then. All right, basic list functions. Write a function that takes any list and any item. That's really sort of the same thing we just did. Write a function that receives a list, and yeah, here we go, this is a good one. So in 29, you want to use pop to remove an item from a list and then print the popped item. And the list in this case was produced these results. Looks like it was okay, here goes define my func. Will receive my list and number. Print my list dot pop, whatever number was, and then return my list. And then I've defined my list up here to run with, so I can simply my func my list plus the number. Let's pop, oh, I don't know, element 3. And it removed 0, 1, 2, 3, which is the number 1, and returned everything else except that.
You lost me, I forgot what pop was.
Pop removes an element from a list at the index specified. So when you pop 3, you remove the third indexed element of the list. So now the list is shorter by that much. Notice that it jumps from 42 to 8.2 because the word 1 has been removed.
Oh, so you return the pop? Oh, you print the
Because I do
pop and
both.
then
I print the pop and then I return the list after it's been transformed. And let's do one more. Using the loop as a starting point, write a function that receives 3 lists and appends the first element of each into a new list. So you should receive this and produce that. This is what your function should do once it's successfully written. Okay, so here comes the answer. We're going to define my func as receiving L1, L2, and L3. And we'll create a new list, which I'm going to call matrix. And I'll set that equal to Let's find the solution code on this is written slightly incorrectly. I'll take those three lists and I'll put them into their own list. And then I'll create a third list called first column, and I'll set it equal to an empty list. And then use a for loop for item in range 0 up to 3, but not including 3. And my first column dot append item. No, dot append matrix index item index 0, and then return first column. And I run that, and then I run the solution, and it is accurate. This is probably the most confusing part of all of this, so I'll pause to talk about that fifth line of my function. I create an empty list, and I use a for loop that simply walks through the numbers 0, 1, and 2. And if you put a for loop that said for item in range 0 through 3 print item, it would simply print the numbers 0, 1, and 2. It doesn't print 3 because ranges are always not including the last element. First call is currently empty, and I use the dot append method to add elements to the list one by one. And the elements that I'm going to be adding are from my previous list called matrix. Matrix has 3 lists, 1, 2, and 3, and each of those lists has an index 1, 2, and 3. So for item in range 0 through 3, 0, 1, and 2, I call matrix, which is this, and I call the list, list 1, list 2, list 3, or list 0, list 1, and list 2. Element 0 is here, here, and here, which is what it is. And I'm calling this the first column because it is clearly the first column of a 3 by 3 matrix. Questions about that? Like I said earlier, the dot append method is really common, especially with for loops, as a way of building out lists. So common that it does have something called list comprehension, which I haven't really touched on yet because I've been trying to keep the notebooks moving forward. But maybe it's about time to finally show you an example of that because it will continue to come up. So I'm just going to go ahead and do that here, but outside of a function. It's not necessarily linked to a function. So let's build a for loop with an empty list. New list is equal to blank. This is not a function, okay? And now I can say for item in the following list, blue, red, green, yellow. For item in following list, new list dot append item, and let's just put the item backwards just to shake things up a little bit. And now when I print new list, it has the 4 colors, but each one's spelled backwards. So the steps here are you create an empty list, you create a for loop, and then you append every item in the for loop to the new list. You can do all, this is such a common Python thing to do that you can do all of it in one line of code as follows. Brackets to indicate there's a list, and the thing you want to have at the end, then the word for, item, in, so basically this. Just drop that in there. And what this does is it eliminates the need for creating a new list that's redundant. Why create an empty list and then build into it when I can just do it in one blow? And that works, and just to make that clear, we'll add another one there. So these two things are equivalent. New list for item append. I'll give you a second example, and then I'll have you build out one yourself. I'm going to call this final list is blank for x in range 1 up to 10. Final list dot append x times 2. Run that and then call final list, and it has successfully multiplied each one of my elements. Try turning this into a list comprehension the way I did with the other one. I'll give you 60 seconds and then I'll give you the answer. All right, so the first thing I do is I create my empty list. Then I go back to my append statement and I grab the thing I want, which is x times 2, and I drop it into my empty list. And finally, I get the for statement without the colon, and I drop that into my list. And now I run that, and that's successful. And if I change the number, it's still going to be successful. X times 2 for x in range 1 through 20. All right, one more example of list comprehension. Empty list is equal to that for value in, and this time I'm going to do a list with a bunch of tuples. 0, 1, these are coordinates. In fact, I'll call them coordinates. Coordinate in the following 0, 1, and the second one is maybe 7, 8, and then I've got 6, 5, 6, 6, and suppose these are coordinates like on a map or something like that. For each one of those, empty list dot append coordinate, and we just want the first element of each one, so it will be coordinate 0. Now I run that, and then I call back to empty list, and it's no longer empty. It got 0, 7, 6, 4. Try to turn that into a list comprehension. Okay, here it goes. So getting rid of empty list. First thing you do is you start with the empty list, grab the thing you want, which is coordinate 0, drop it here, and then grab the for loop without the colon, and bang, you're good to go. And if I add another coordinate in there, 7, 3, it will grab the 7 appropriately. All right, the last challenge then is to take this same exercise we saw earlier and redo it so that, and this is L1, turn this into the same function but using list comprehension. Okay, so I copied the whole function down into a new cell, so I've got them side by side. And clearly, the part that is list comprehension is these 3 lines. This is what I need to replace. So I'm going to delete them. And I'm also going to delete first call, because I can just put it all into my return statement. And here goes the list comprehension. You start with a blank list. Grab the thing you're interested in, which in this case is well, this is slightly different. What we want is the first index of each row for row in matrix, which was defined above. So just really 2 lines of code instead of 5. Run that. Run this one up here to get my lists defined. And there we go. And if I change my list, if I change this to be 3, 5, and 2, for example, then my list comprehension works successfully. So it returns row 0 for row in matrix. All right, show of hands. Who was able to get that successfully? Yeah, a couple folks. Those of you who didn't, would anybody like to ask a question about that or a clarification in the element of functions or list comprehension? Or is this just all like, wow? Well, list comprehension is something from, I think, repository 3 that I didn't spend a lot of time on. But now you have it, and if you'd like to have some refresher on it, there's obviously lots of materials out there that one could go back to. It doesn't come up too often, but it comes up from time to time. All right, let's see if we can squeeze in one more. We've got 5 minutes left. Functions with dictionaries. And I'm going to clear out the output on this one. Oh yeah, because it's already, yeah, that's why. So we'd like to write a function that receives any 4 items and converts them into a dictionary with 2 keys into 2 values. So I would define my func as receiving A, B, C, and D. Those are the 4 items. and I want to return it with a dictionary. So my dict will be equal to A is to B as C is to D, return my dict, and then we've got my func. We'll feed it blue, red, yellow, green, and it gives it back to us as a dictionary. Blue is to red, as yellow is to green. Try the same thing in the next one. Write a function that receives 6 items, converts them into a dictionary, then calls the value of the first key. Ooh, that last part might be tricky. 1 minute. Okay, and here comes the answer. So we'll define my func as receiving 6 items, and we'll create a dictionary called Webster, and we'll set Webster as equal to A is to B, as C is to D, as E is to F. And then we want to return not the entire dictionary, but simply the first key, which is A. And now, when I go ahead and I pull these guys down, drop them in here, and let's add a few things. Blue, spicy. So we'll combine colors and tastes. Spicy, crunchy, and yellow can be sweet. So if my function has been written correctly, what word will it return from this dictionary? Spicy, because it's calling the first value of the first key. So if I would like for it to return the word sweet, what would I need to change in my function? Exactly. And if I wanted it, this is a little more difficult, but what if I wanted it to return the word red? Red is a key, it's not a value. That's a little trickier. Anybody? How do you get it to return the word red? Yes. Let's start with that. So if I have it return .keys, it'll give me back the 3 keys, red, blue, and yellow. So now if I want it just to return red, can I do this? No, that's an error message because this isn't a list. So I have to turn it into a list and then call back the first element, and now it gives back red. Cool. Last exercise, we'll stop with this one, nested dictionary functions. Assume you have the following dictionary. I think I must have accidentally deleted this one. Okay, so the dictionary looks like this. Write a function that returns the most deeply nested value. Miriam is equal to key 1 nest key subnest key value. So how do you give it? How do you get it to return the word value? Okay, and here it comes. Define my function as receiving any dictionary, and then it should return any dictionary, and we assume that the dictionary has those keys, key 1, and if we left it at that, and then we did myfunc Miriam, what would it give us? It would give us the word nest key subnest key value, right? Because that's the value of key 1. So then let's go ahead and give it a second key, nest key, and now it has something shorter, and you can see where this is headed. We're going to go ahead and we're going to grab that key and drop it here, and now we finally get down to the word value. And if you wanted this to be a little more generic, you could do any dictionary dot keys, or even better yet, before printing it, you could set that equal to a new variable called keys, turn that into a list, and then call elements in that list, and it would make it, I'll print that one. And this would be a way to call back individual lists, individual keys, without having to actually know their names ahead of time. Okay, cool. Well, there's a lot more that is here. I think that if you go through the solution notebook, these exercises are actually pretty straightforward. I'm sorry I wasn't able to cover all of them tonight. But the solutions notebook, it kind of walks you through a whole bunch of examples that practices how to build functions and how to build them with dictionaries. I will say that this particular exercise does get used a lot when you start doing any kind of web scraping or API reading, because everything that you get back from a website will be in JSON format, and parsing stuff out will require this sort of function writing. Okay, cool. Well, I hope that was helpful. Please take a second before you go to leave me some feedback in the exit tickets about anything that was useful or less than useful. Keep in mind that we are hoping to present interim projects, let's call them, 1 week from today on October the 3rd, Thursday, and this is for Lear. Lear, I missed this before I started the recording, but the idea is to build a very simple Plotly Dash app and display it to the class at the beginning of class next Thursday. So select me if you got questions about that.